Hello everyone, and welcome to section 8.3, which is going to be graphing reciprocal functions. So we have a new type of graph. It is called a hyperbola graph, or sometimes just called a reciprocal graph. It does kind of look sort of like two parabolas that are kind of facing in opposite directions. Our domain and range for our parent function is all non-zero real numbers. And our asymptotes are x is not equal to 0 for our horizontal asymptote, and then we also have an asymptote with the x-axis, or y equals 0. And of course it's not defined at x equals 0 because that would give us a denominator of 0. Now for these functions in general, we'll have an a on top, a x minus h plus k. This should look familiar. Our horizontal asymptote will always be that k value. Our vertical asymptote will always be the h value, and remember the h is always the opposite of what it looks. The a value tells us how close or far away we are from the asymptotes, but more importantly tells us if we are in the theoretical first and third quadrant or the theoretical second and fourth quadrant. So if a is positive, it's going to look exactly like this purple one. If a is negative, it's going to look like this red one. Maybe closer or further away from the asymptotes, but that's their general form. And of course, we're not defined at the x equals h values, which would make our denominator 0. We are just going to do sketches of these graphs, so not actual points, so it is important that you kind of keep in mind, okay, is my a positive or is my a negative? So if I had a graph and I just wanted to identify the asymptotes, domain, and range, so I'm looking and I see h value of -2, a k value of 1. So I know my asymptotes are going to be y equals 1, since y equals our k value, and x equals -2, since x equals our h value. And then my domain and range. Domain is everything that is not equal to our -2 from our asymptote. And our range is going to be everything except our asymptote again, which in this case is 1. And for graphing these, so I see I have a negative a value, so I am going to be flipped. I am going to have something kind of over here and something over here. I have a asymptote at x equals -1, so I'm going to go ahead and plot that, and you do absolutely have to graph your asymptotes for these guys. And then I also have an asymptote at y equals 3. So, since I'm negative, I know I'm going to have something over here and something over here. So pretty much we just kind of are hugging our asymptotes, but not quite reaching it. So my domain, we can say all real numbers instead of x. So all real numbers not equal to -1. And our range is all real numbers not equal to our value of 3, which is our k. And there are some word problems. They are going to be fairly simple. So for example, if I had a commuter train and they were 25 miles apart, just write an equation that represents the time traveled between the two cities as a function of rail speed. So if I'm using like my distance equals rate times time formula, and I'm solving for time, since I want to represent time, I would divide both sides by r. And then since I'm told that my distance is 25 miles, I'd plug in 25. And that would actually be my answer. If I had a follow-up question asking how long would it take to get to the city if I was traveling 50 miles per hour, I would just plug in 50 for my rate. And I would get 0.5 hours, which we know is 30 minutes. That's about it for this section. I'll see you in class.